Hello, sir. My name is Alia Gil Morales, and this is my report for Architecture and Organization. So, let's start. First one, Introduction. The fetch, decode, execute cycle is the fundamental operational process of a computer central processing unit. It describes how the CPU retrieves instructions from memory, interprets them, and performs the required operations. This cycle repeats continuously from the moment a computer is turned on until it's shut down. Understanding the FDE cycle is crucial because it explains how software instructions are transformed into actions that a computer can perform. Topic: Overview of the CPU components. So, to understand the cycle, we first need to know the important parts inside the CPU. So, let's start. Number one is program counter or PC. Hold the memory address of the next instructions to the fetch. So, this keeps track of where the next instructions located in memory. Number two, memory address register. Store the address or data that the CPU needs to access. So this PC is keeps this holds the address of the data instruction the CPU wants to access. Next, 2.3 Memory data register. Temporarily store data or instructions coming from going to a memory. So, ang memory data is this stores the actual data or instructions being transferred. Number 4, current instructions register. Hold the instructions currently being decoded and executed. So, this stores the instructions the CPU is currently working on. 5, performs arithmetic and logical operations. This is performs calculation and logical decisions. And 6, control unit or CU, directs operations of the processor and coordinates all activities within the CPU. So this acts like the boss of the CPU, directing all the components and making sure everything works together correctly. The FDE cycle consists of 3 main stages. So, meron stages ang FDE. So, let's start. The first one is fetch stage. The purpose of the stage fetch is to retrieve the next instructions from main memory. Steps. Number 1. The program counter PC sends the address of the next instructions to the MAR. The memory address is used to fetch the instructions from RAM and load it into the MDR. Number 3. The instructions is moved from the MDR to the current instructions register. Number 4. The PC automatically increments to points the next instruction. So, the first step is fetch. Here, the CPU gets the next programs or instructions from memory. The program computer sends the address to the MAR. Memory sends the instructions to the MDR. And then the MDR transfers it to the CIR. After that, the program computer or program counter increases so it's know where the next instructions is. So next stage is decode. So the decode stage is handled by the control unit. This is the steps. The CIR examines the binary instructions. The control unit interprets the opcode or operation code. The CU identifies what operation must be performed, what operands or data are required. The CPU prepares the necessary components such as the ALU or the registers. So the next stage is decode. In this stage, the control unit reads the instructions in the CIR and interprets and what needs to be done. It figures out what operation is required and what data or registers will be used. So here we go at the execute stage. In this stage, the CPU performs that operations defined by the instructions. Possible actions include arithmetic operations, add, subtract, multiply, and divide, logical operations, and or not, data transfer, which is load, store, and move, input-output operations, branching or jumping to other instructions, and once execution is complete, the CPU repeats the cycle for the next instructions. So the last steps of stage So the last step is execute. Here, the CPU actually performs the operations. This may be doing a calculations, moving data, storing information, or jumping to another instructions. After the operation is done, the CPU starts the cycle again for the next instructions. Step is the importance of FDE cycle. So it allows computers to run programs efficiently and consistently. It breaks complex software into small, manageable, machine-level tasks. It ensures organized execution of operation in a controlled manner. And it is the core process that enables automation in computing. So FDE cycle is important because it makes sure computer run smoothly and correctly. It breaks tasks into small steps that the CPU can handle and keep it all operations organized. And without this cycle, computers would not be able to follow instructions to run a program. And application in real computing. FDE cycle is used in running operation systems, executing application and games, and processing user commands, managing system hardware, performing calculations and engineering and science. Every action a computer performs, from opening a file into or loading a web page, relies on this cycle. So, this cycle is used all the time in real computers. It runs the operations, systems, games app, hardware, processes, and even simple user commands. Every action we do on a computer is made possible because of the fetch, decode, execute cycle. So the last part is conclusion. The fetch, decode, execute cycle is the heartbeat of the computer, or the central processing unit. It continuously processes instructions by fetching them from memory, decoding their meaning, and executing the required operations. Without this cycle, computers would not be able to perform tasks or run any programs. Computer would not be or Understanding the FDE cycle provides a deeper appreciation of how computers functions at their most essential level, and highlights the importance of the CPU as the brain of the systems. So in this conclusion, the FDE cycle is the core process that allows computer to operate. It fetches instructions, decodes what they mean, and executes them. This repeating cycle is what makes the CPU function as the brain of the computer. Understanding these cycles help us appreciate how components perform tasks so quickly and accurately. That's it. Thank you.